Hi everybody, so today we're going to be adding and subtracting radical expressions, and you have your note sheets at home and you'll see that there's A through F as a warm-up. What I'd like you to do is, at this point we've been talking about radicals for a long time and we've been doing all different types of operations on them. We've been simplifying, we've been multiplying, we've been reducing, we've been rationalizing. I'd like you to go ahead and do A through F. And tomorrow I'm going to check to see really how much do you know? Are you getting closer to being ready for a test on this material? All right, but today we're going to be doing some fun stuff. We're going to be adding and subtracting radical expressions. I know, it sounds so fun, doesn't it? All right, so I want you to think of adding and subtracting radicals. I want you to think about it as the same thing as adding like terms, okay? We've spent a lot of time this year talking about like terms. Okay, x and 2x. Variables are the same variable raised to the same power. They are like terms, whereas x squared and x are not like terms. Why? Because they're not raised to the same power. Radicals are extremely similar to like terms because although you don't know it yet, the square root of x is actually could be written as x to the 1/2 power. That's actually what it means as an exponent. So if I wanted to compare just a plain old x and x to the 1/2, they aren't like terms because they're not exponents. They don't have the same exponent. All right, so let's talk about what we would do with like terms. If I gave you x plus 3x, well, they're like terms, so you can add them together. So you add the numbers, the constants, but you never change the x. You don't multiply the exponents and make it x squared. That would be power times power. That would be multiplying exponents. All right, so we're going to do the same thing. So let's look at our first example. Root 2 plus 3 root 2. The radicals are exactly the same. And there's a hidden 1 in front of that 2. So we basically have 1 root 2's plus 3 root 2's, which would give me 4 root 2's. Okay? Let's try another one. 8 root 3 plus 3 root 3. All right, so we have 8 root 3's and we have 3 root 3's, which is, I hear you saying it, 11 root 3. Okay? Got it? All right, let's look at different examples. Now I've got radicals, and unfortunately, these aren't like terms. I look at them like, oh, they're not like terms. But we've been spending time looking at what you could do to root 12 to make it maybe possibly have root 3 in it. You can simplify it. All right, remember, we want the largest perfect square that is in the number 12. And I know that if I break it up as the square root of 4 times the square root of 3, 4 is the largest perfect square in 12, so it would become 7 radical 3 minus, square root of 4 is 2 radical 3. All right, now, are they like terms? Jackpot. So I can subtract them. So 7 rad 3 minus 2 rad 3 is 5 radical 3. Okay? All right, hopefully you can see that. All right, let's look at our next example. I just made the numbers a little bit more difficult. And actually, I'm going to change the color on it because I don't know if you can see it that well. So 8 root 5 minus root 45. Now, you may hear me saying radical or rad or root. I like rad because anything's really cool, it means it's rad. But those are all words that we can use that mean the same thing, right? We could say this is root 5, we could say this is radical 5, or we could say this is rad 5. All right, now they're not like. So in my mind, Coach Fred's thinking, I really have got to simplify this 45 if I can. And actually, I'm thinking a little bit ahead of myself because I'm like, well, I want it to be root 5 times something. Well, root 45, if you remember, the largest perfect square in 45 is 9. So we can break it up into root 9 times root 5. There's that root 5 that they have in common. So, simplified, we have 8 root 5 minus 3 root 5. 8 root 5 minus 3 root 5, therefore gives me 5 root 5. Okay? All right. Moving on. I'm going to play with your head now. Look at that. That says 9 root y plus 3 root y. So I don't have numbers under the roots anymore. I have have variables under the roots. All right, same exact thing. You ask yourself, are they like terms? Yes. So I can add them or subtract them. So I add the 9 and the 3 and I get 12 root y. Done. So simple. All right, harder. Oh gosh, Coach Fred, you gave me 2 radicals and they look nothing alike. Because they aren't. They are not alike. They're not like terms yet. All right, so we look at 45. We've already reduced 45 to 3 radical 5. All right, and we're going to reduce 20. And if you remember, 20 is the square root of 4 times the square root of 5, which gives me 2 radical 5. Okay, so now they are like terms, so I can subtract them. 3 root 5 minus 2 root 5 gives me plain old root 5. Now, some of you might want to put that 1 in front, but you know, we don't normally write 1s as coefficients in front of things. So I think at this point, you can write it as just plain old root 5. Okay. Hopefully, so far so good. Can make it a little bit more difficult. This is probably the most difficult right now, and we're going to be practicing this tomorrow in class. So, but oh, that's not also clear, is it? New page. Let me do a new page. So I have radical 2 over 7 minus